Egypt is building Africa's first ever high-speed rail network, a 2,000-kilometer-long system that links 60 cities, slashes travel time in half, and connects two seas, the Red Sea and the Mediterranean. Trains will fly across the desert at 250 kilometers per hour, cutting the Cairo to Hurghada trip to just 3 hours. It's the sixth largest high-speed rail project in the world, and the cost? Over $23 billion. It's a rail Suez Canal on tracks. But here's the twist. They're building all of it from scratch, in extreme heat, across mountains, rivers, and empty desert. So how do you electrify 2,000 kilometers of Egypt's toughest terrain and keep trains running through sandstorms? Let's find out. Egypt is a nation of 110 million people, with one of the youngest populations on Earth. But its transport network? Slow, outdated, and overcrowded. Cairo to Luxor by train can take 10 hours or more, and cross-country roads are long, risky, and often jammed. For a country that wants to rank among the top 30 economies by 2030, that simply won't work. So, Egypt made a move, a big one. In 2021, the government signed a multi-billion-dollar deal with Siemens Mobility, Orascom Construction, and Arab contractors to build the country's first high-speed rail system. A fully electric, 3-line network that can handle passengers, cargo, and rapid regional growth. This wasn't just about new trains, it was about new cities, new jobs, and a new way to move. The network is being built in 3 phases, each one massive, each one changing the map of Egypt. Let's start with the first line, the Green Line. This is a 660-kilometer stretch that starts in Ain Sokhna on the Red Sea, in Egypt's east. From there, it moves west to the new administrative capital, just east of Cairo. Then it heads across southern Cairo, through 6th of October City in Giza, and into Wadi El Natraoun, a desert valley northwest of the capital. It continues into Borg El Arab and then Alexandria, before finally ending at Marsa Matruh on the Mediterranean coast. This line links 2 major ports, Sokhna and Matruh, creating a coast-to-coast transport corridor. Think of it as Egypt's land-based Suez Canal. This section alone includes 21 stations, 13 for high-speed travel and 8 for regional service. With an operating speed of 230 kilometers an hour and a design speed of 250, this route will carry up to 30 million passengers per year. Now to the second line, the Blue Line. This one is even longer, at 1,100 kilometers. It starts from 6th of October City near Cairo and heads south along the west bank of the Nile. It passes through Fayoum, Minya, Asyut, Sohag, Kena, and Luxor, before ending at Abu Simbel, close to the Sudanese border. The line also has extensions in progress to Toshka in Egypt's southwest desert and to Wadi Halfa in Sudan. This line is a north-south artery connecting central Egypt to its southernmost edge, while also building trade routes with sub-Saharan Africa. The third and shortest line, the Red Line, runs for 225 kilometers between Luxor and the Red Sea. Starting in Kena, it heads east through East Sohag and stops at Hurghada and Safaga, 2 of Egypt's most important Red Sea ports and tourist hubs. This route connects tourism, agriculture, and freight, forming a key part of the national logistics network. So how do you build 2,000 kilometers of electrified railway through sand, rock, mountains, cities, and nothingness? It all starts with the track bed. Construction crews first removed over 11 million cubic meters of soil, more than what was moved to build the entire Panama Canal. They backfilled 3.5 million cubic meters of engineered material to form a stable rail base. This process was especially tricky in the desert, where loose sands shift constantly and can destabilize infrastructure. To solve this, engineers use basalt rock bedding under the rails, strong, durable, and heat-resistant. On top of this, precision-aligned rails are installed, supported by concrete sleepers that resist extreme temperatures and vibration. Electrification is next. This system runs on overhead catenary lines, wires suspended by poles every 50 meters or so. These carry the electricity needed to power the trains. To handle Egypt's climate, Siemens uses corrosion-resistant, low-maintenance contact lines supported by gas-insulated switchgear systems. Substations are spaced across the network to ensure consistent power delivery. The first 4 transformers and 2 substations are already installed. On the tracks, there's the Velaro, a high-speed electric train specially designed for Egypt. It's 200 meters long, with 8 carriages and a top operational speed of 230 kilometers an hour. Each Velaro can carry 481 passengers in standard, business, and restaurant compartments. Its body is sealed to block out desert sand, and it has high-efficiency filters to keep the air clean, even during sandstorms. Egypt has ordered 41 of these trains for the high-speed network. There's also the Desero, slightly slower at 160 kilometers an hour, but perfect for regional routes. Egypt will receive 94 of these for short-haul service. For cargo, the network includes 41 Vectron freight locomotives, each capable of pulling heavy loads across long distances at 120 kilometers an hour. Signal systems follow the ETCS Level 2 standard, Europe's gold standard for rail safety. Trains communicate in real time with centralized control centers, reducing headways and maximizing safety. Siemens also developed digital power managers to reduce energy usage and improve station efficiency. The central control room for the first line is in New Capital Station, east of Cairo. This is a 578-acre hub with 39 buildings, maintenance bays, inspection workshops, parking yards, and control towers. It's Egypt's most advanced rail facility ever built. Here, engineers monitor train status, energy consumption, and predictive maintenance alerts in real time using Siemens' Railagent X platform. Station design also matters. Giza Station, for example, connects to the Cairo-Aswan Railway. October Gardens Station links lines 1 and 2, and 6th of October Station connects to the West Nile monorail. Each of these hubs is being built with smart ticketing systems, integrated parking, and commercial zones to support nearby cities. But the most ambitious part of this project? The scale. This isn't just a few cities and a few trains. We're talking 60 cities across Egypt, over 60 stations, millions of passengers, thousands of tons of cargo daily. The full system will create 500,000 direct and indirect jobs. That includes construction, maintenance, operations, logistics, and tourism. And it's all being built under tight deadlines. Phase 1, the 660-kilometer Green Line, is set to finish in 2027. Phase 2 and 3 are well underway, with earthworks, bridges, and track laying already in progress. The total investment? $23 billion, making it one of the largest infrastructure projects in African history. It's also a green project. High-speed rail cuts emissions by 70% compared to driving or flying. Egypt's new network will remove tens of thousands of cars from the road, cut air pollution, and link agricultural hubs like the New Delta and Toshka directly to export ports. The lines are designed to integrate with airports and seaports across the country. Sokna, Alexandria, Marsa Matruh, and Safaga are all getting logistics terminals. Airports like the New Capital, Luxor, Aswan, and Sphinx will be directly connected. This is multimodal transport on a continental scale. And Egypt isn't stopping there. Plans are in motion to extend the lines to Libya's Benghazi and Sudan's Wadi Halfa. There's even talk of connecting deeper into Africa, creating a transcontinental rail spine. That would make Cairo not just a national hub, but a gateway to the continent. This project is ambitious, but it's not without criticism. $23 billion is a huge cost, especially for a country with economic challenges. Critics also question whether rural Egyptians will be able to afford the high-speed fares, or whether the network will mostly benefit the urban elite and international investors. There's also the environmental concern of building across fragile desert zones and archaeological sites. Construction delays and corruption risks are always a possibility with projects of this size. But Egypt's government insists this isn't just a headline project, it's a full transformation. International partners, including the World Bank and German banks, are backing safety and logistics upgrades. And with Siemens contracted for 15 years of maintenance, there's a clear path to long-term reliability. If Egypt delivers on time and on quality, this will be Africa's first true high-speed rail network, setting the stage for a new era of mobility across the continent. If you're excited about this leap into Africa's rail future, hit like, tap subscribe, drop your thoughts in the comments, and don't forget to turn on notifications.